Hello! Welcome to Ask a Reporter for another week. My name's Nathan, this is Carl, and firstly, very sorry we are late. We just had a few technical difficulties, but we are back live and streaming, ready to go. Carl?
Basically, I just wanted to get my coal-coloured shirt on, but I'll let Nathan decide whether he thinks it's clean or not. I'm not so sure myself.
Jury's out, not sure. Did he clean it? Didn't he clean it? Let us know. Tweet your answer now using the hashtag #AskAReporter. Is Carl wearing a clean coal shirt or a dirty coal shirt?
Maybe just a coal shirt. We'll leave it at that. We don't need to speculate on this one.
No smell-o-vision, thankfully. We've got heaps of questions from you guys, so we're going to jump into it. Carl is going to go as quickly as he can through as many questions as he can because we want to get through all of you in the next half hour. So buckle in. We're going to have some fun. Let's go. Clean coal. We're going to start with Year 5 at St Andrews, and Christina, Fallon and Ava want to know, what would we use if coal runs out and solar, wind and water isn't reliable enough? What other options are there?
It's a really great question. I mean, I've done a few stories now on alternative energy and fossil fuels, and it's really interesting when you look at this because there's a whole bunch of different options. Some of them are really tested and proven, and others are still sort of getting to that point of being up and running and reliable. So the traditional ones that humans have used for the last maybe 100 or so years have been coal, gas, and oil. And they're all fossil fuels. But more recently, we've also been looking at solar, wind, water, and even some more experimental ones like bioenergy, where you have sort of degrading organic matter that creates gas that you can burn for energy. So there's lots and lots of different options, but the main ones are coal, gas, and oil. And then in terms of your renewables, you've got things like wind and solar, some wave energy. And if we stopped using coal, a lot of people in the government and in the opposition party and scientists as well say that, yeah, we'd want to switch towards more renewable energy, but a good intermediary, like one in the middle to get there, is something like gas. Gas is a little bit better for the environment when you're burning it, but it's also something you can switch on and off really quickly like coal, so it's a bit more reliable.
Cool. Speaking of that sort of renewable versus coal kind of thing, Henry, Theo, Jack and Alex all want to know, why do we use coal instead of renewable energy? What's the benefit to coal?
Well, Australia is incredibly lucky when it comes to coal reserves. So we're one of the biggest producers of coal in the world. We've got loads and loads of coal underneath the ground here in Australia.
This shirt.
Yeah, and on my shirt here in Australia. So we've got a lot of coal. We've always had a lot of coal. We use a lot of it here in Australia. We export a lot of it overseas for other countries to use as well. So because we've got such a big coal industry, it made a whole lot of sense when coal was the main energy source to use lots of coal. So we've got lots and lots of coal power plants. So all of that infrastructure is there and it's good and ready to go. Some of it's getting a bit older now and some of it's not running as well as it possibly could. So it's not this new clean coal technology we've been talking about, it's some of the older stuff. And so that means that people are looking now at, well, we've been using lots of coal for a long time, but maybe it's time to change and look at something different.
Okay, so Isaac, Angela and Macy want to know, why don't we use then more solar and wind? What are the problems with solar and wind?
Solar and wind, maybe over the last 10 or 15 years, have really become much, much better. They become more efficient, which means that they're better at collecting energy. And they become more reliable, which means that even in really sunny or not so sunny, or in really windy or not so windy conditions, you can still get energy from them. But the extremes still really muck with the system when you've got wind and solar making up a big share of what's in your energy mix, like here in South Australia. And that's because if the wind blows too hard, those wind turbines that are spinning around, they have to stop, otherwise they'll break. Or if it's really, really cloudy for a lot of days, then those solar panels aren't going to pick up enough energy. And at the moment, we don't have very good storage. We don't have very good batteries in the system to store up energy ahead of those cloudy or really windy days. So at the moment, we have to rely on them still spinning, still absorbing energy, and when we have a bad run in the weather, then that means that they shut down and they're not as reliable as other options.
Next up, we're going to Rameth from HWA School. If clean coal power plants can trap CO2 underground, which we said in the story, would it damage the soil around the power plant? Do we know that yet? Because it's still kind of experimental, isn't it?
Yeah, God, these are great questions, by the way, guys. Nice work. So this one is a really interesting one. This idea has been around for quite some time. And the term they use for it is carbon sequestration, which is a really weird word. But they've been talking about this stuff for, over a decade now. And they've done lots and lots of studies on it. They've tested it out. They've tried to see how it's going to work. And basically, they think they've got it pretty close, but there's still a lot of question marks around it. And some of the things that people are worried about are, how safe is it to store carbon dioxide underground? Maybe it's going to leak into the soil. Maybe it's going to leak into water under the ground as well. Or maybe if there's like an earthquake, then the whole chamber could open up and the carbon dioxide just goes back up into the atmosphere. So it's technology that's quite interesting and quite promising, but there's still a few question marks that some scientists and experts have about these ones as well.
Okay, another great one from Jason at HWA School. The story said CO2 is 3 tons heavier than coal. How do you measure the weight of a gas? Great question, Jason.
Yeah, it's a good question. It's for people much smarter than I am. But the reason why you've got 3 times as much is because when that carbon breaks up, it combines with oxygen. So that formula CO2, that's 1 part carbon, 2 parts oxygen. So that's why you increase the weight of the carbon, basically. But it's a really tricky one in terms of actually weighing gases. I've never done it. Have you been able to weigh a gas before?
No, I haven't. I know, there's obviously the way that they estimate the weight of gases depending on, different environmental factors, like how hot it is, that gas, because gas changes its volume so dramatically with different temperatures. And they kind of can roughly estimate with a certain volume how many carbon dioxide atoms molecules are floating around in there, and then they kind of roughly know the weight of some of those, and then they can, but it's very much, I don't know how you accurately do it at all.
Yeah, I mean, we're constantly surrounded by little atoms, particles floating around in the atmosphere. They're just really spread out. They're not chunked together like that bit of coal I was holding in the story. So
that's one, just here.
So as they're floating around us, they're hard to measure, but scientists have found ways to figure out how it all works, and I don't know much about that one, so maybe that's where the Google search as well.
Sorry. It started off being a carbon dioxide atom and it turned into more like Pong, and I don't know.
He's easily distracted.
I am. Yeah. Leah from HWA says, have any other countries trialled clean coal? Are any other countries using clean coal?
Yeah, so when I was doing some research on this one, I was looking around at sort of where we're at with clean coal technology. And there's a bunch of different countries that are doing research, they're trialling the technology. One of the big countries is the United States. They've been trialing this clean coal technology. But unfortunately, it's not been tried and tested yet and proven to work 100%. So there were, I think it was like 20 or so clean coal power plants that they set up in the United States. And as of this year, none of them are still up and running because they either proved too expensive, too difficult, or just not efficient enough to really make it worth it. So they're still in that process of trialing it, and there's countries around the world that are working on different ways of kind of tweaking the system to either burn it at higher temperatures or filter things out differently. There's all sorts of technology they're looking at to make things cleaner, but none of them are really sort of 100% there yet.
Okay, Gus wants to know, he's from HWA School as well, can clean coal produce the same amount of energy as normal coal?
It's a really interesting question. I mean, so the equation is basically you've still got the same amount of coal that you're going to be burning. But like we were saying in the story, when you have to burn it at higher temperatures, then you're going to have to put in more energy into burning it at higher temperatures as well. Thankfully, you do get a little bit more energy out, but in terms of how efficient that is, that's one of the problems they've been having in places like the US in those trial plants, getting the efficiency right so that the amount of energy you're getting out on the other end is balanced by how much you're putting in with those higher temperatures. So at the moment, the idea is, yeah, we should be able to get as much, but there's been a few problems in getting the right amount of energy out of that same chunk of coal when you're putting that extra heat in the mix.
Okay, we're going to a question from room 1 now with Miss Jess as the teacher. After coal is burnt, how does it create power? Great question there. How does a coal power plant even work?
Yeah, so it's quite interesting. And again, there's different ways of doing it. There's different technology out there. But the most common one, the most sort of basic one, the one that we talked about in the story as well, is you burn the coal and it creates steam. And that steam will turn a turbine, and the turbine will generate power. And the steam comes from sort of water. So the heat boils water, the water turns to steam turns to turbine makes power for us. So that's the kind of basic way of doing it. It's way more complicated than that inside those places. A lot of them are still pretty basic, but some of the newer ones especially very complicated. But that's the kind of basic idea that they've got working in there.
And that's what most of our power generation is, isn't it? It's just different ways of spinning a turbine.
Yeah.
And most of it is different ways of heating water or a liquid to create steam to turn a turbine. It's just different ways to achieve the same thing.
And I mean, if you want to get rid of all of these different energy sources altogether, you can just get people on bicycles, and they could be spinning their own little mini turbines in their house, at school maybe, while they're at work sitting at their desk.
I've done that. Well, I had a light on my bike. You know the little dynamo things?
Oh, that's it. Yeah.
Little turbine, and then you have a light on the front. I don't think they do it now because LEDs are so efficient, but back in the day, we all used to do it. We're all little power generators.
Yep. So the principle's the same. When you jump on the bike and you pedal away, you're spinning something, and that creates motion for you on the bicycle. But if you run an electric cord up to the little lights at the top of it, then when you pedal, spin the thing, that creates a charge, some energy, which lights up the light. With power plants, you're just capturing that charge, that energy, and sending it onto the grid so that you can power people's homes or their classrooms or Twitter while they're watching Ask a Reporter.
In retrospect, that made me sound very old.
Oh.
So that's a bit sad. Miss Jess's class, room 1, also want to know, how can Australian people have a say on this issue? So some kids out there might be for clean coal, some might be anti-clean coal and want renewables, some might want to tell politicians just to, have a good mix of the two. How can they do that?
There's lots of different ways that even kids can be quite active in terms of how they influence politicians or policies, the things that our country is doing. Some of the things you can do are things around your school or your classroom. So you can reduce your energy usage if you want to try and save on the amount of energy going into the system. You can talk to your parents about what their energy provider is doing. A lot of energy providers are using a mix of energy sources. A lot of them are using coal and gas and oil, but some are all renewable energy. So your parents or your school might be able to switch to a renewable energy company. And then there's things like actually writing a letter to your local politician or even to the PM if you want, as a classroom or by yourself, and saying, hey, we think this is a good idea, we think we should do clean coal. Or maybe you'd say, oh, well, we're really interested in doing renewable energy. Why aren't we doing more renewable energy? And just those letters, they make a big difference. It's kind of people power in a very simple way, and you can talk to your local politicians or the politicians right at the top. And if you group together with other people, there's even things like petitions online. So there's lots of different options out there that you can be an engaged citizen in Australia and help shape what's happening in terms of our energy policy.
Next question's from Woodend Primary School, and Verity there wants to know, could we put a carbon dioxide filter, because we talked about putting carbon dioxide filters on power plants to try and clean them up a little. Could we put one of those onto factories that create carbon dioxide to protect the environment there as well?
Yeah, so
good question.
It's a great question, Verity, and there's already a bunch of different filters in place to get rid of those particles of pollution that go up into the atmosphere, whether it's from power plants or from factories. And the earliest filters were things like sulfur filters or nitrous oxide filters, and they pulled out all of those nasty particles. You can also pull out dust with just a really basic filter. The carbon dioxide one is a bit trickier. From what I understand of it, and that's not a lot, I think you have to pump the smoke from the factory or from the power plant through some water, and the water or whatever the liquid is binds with some of that carbon dioxide and pulls it out, and then you can turn that into carbon dioxide elsewhere. The problem is that's quite a difficult process as far as I can understand, and possibly an expensive one as well. So even though it's there and you can use this process to pull out carbon dioxide, you've got to weigh up, well, how much is it going to cost? Is it going to be tricky? You know, is it going to be efficient? Is it going to slow the thing down? And that's what a lot of these people working on new clean coal technology have been looking at, you know, how to get that balance really right. And can you put it onto factories? You can, if your factory is using or burning a lot of stuff that's turning into carbon dioxide. But a lot of factories are pulling in power from power plants elsewhere and then doing their own sort of things in there. Depends on the factory as to what they might be doing. They might be making, I don't know, cans or steel or whatever. And sometimes there would be some carbon dioxide there or some other pollution there. And most of those new factories do have filters on them as well.
That's a very good one. Nick wants to know from Woodend Primary School, does carbon dioxide have an effect on just air quality? You know, that pollution that we can see, or does it have another effect on the ecosystem as well?
Yeah, well, I mean, carbon dioxide is a really interesting one. It's the stuff that we breathe out. So you breathe in oxygen, and you breathe out carbon dioxide. So we are breathing out carbon dioxide all the time. And carbon dioxide, just by itself, is a natural part of the system. And in fact, plants need carbon dioxide. They breathe carbon dioxide in and they breathe oxygen out, the opposite to us. So we need carbon dioxide to some extent. The problem is there's lots and lots of it that are coming out of burning fossil fuels and other things like that. And that's creating an imbalance in the system. So carbon dioxide itself is probably not necessarily a pollutant. It's not going to change the air quality, make you, you know, when there's a little bit up there, that's fine. It's not going to make you really, really sick if there's just a little bit there or anything like that. But it's when you pump up those levels to really, really high amounts in the atmosphere that things start to change. It can be damaging for the Earth's climate system. So that's what we're seeing at the moment with climate change. Greenhouse gases like carbon dioxide and a bunch of others are changing weather patterns. They're making it warmer in some places. So that's the real effect of carbon dioxide. And in small amounts, it's definitely not a pollution. Problem is there's just a whole lot of it up there at the moment.
Okay, we are running out of time, but we have heaps of questions, so we're going to go in a quick fire round for Carl. Okay, so answering quick questions here.
Burn through these cold questions.
Burn through them. We are going to power through this like the coal power stations that we're talking about. Skylar wants to know, is coal linked to, how is coal linked to items like the plastic lunchbox at the start of the story?
That's really interesting. So coal can be used to create plastic and fertilizers. And like it actually goes into, like they pull out some of the parts of the coal and turn it into plastic and fertilizers. Plus, on top of that, the energy from burning coal goes into making things like plastic or a whole bunch of other things that you'll see around you.
Tristan wants to know how much coal is burnt each year. I don't have numbers on that. I was looking for this earlier. Did you see anything?
I think the estimate I've seen is around 8 billion tons, which is a lot of tons. That's a huge amount of coal each year. And I think that was 2010 or 2011 or something that number came from. And it's probably changed a bit since then, but it's somewhere around that 7 or 8 billion tons, which is a huge amount.
Alex wants to know, how did people work out how to turn coal into energy? How did that happen? It's hard to know. It was a long time ago.
Yeah, I don't know the guy who did it, but I'm sure he was quite famous in his town when he figured out that he could burn this rock.
Tuck up stuff and you light it on fire. Imagine finding a rock and you can light it on fire and it burns.
Bizarre. You know, the first guy picks up a rock from the ground and happens to light it on fire somehow, and then it's like, oh wow, this is great. This stuff burns, and then falls into a turbine and figures out that the steam from the rock burning that he found on the ground. You know, I'm not exactly sure about the process, but I'm sure he was a very interesting person, or maybe a group of people who figured that one out.
Okay, now we're going to St. Joseph's at Hawthorne. Newbies, thank you very much for tuning in. We've got some questions here. Can you burn other things than coal to create power?
Yeah, so things like gas that we talked about before is a really interesting one. Sorry. Gas is another fossil fuel, and you can burn it like you might burn coal, but in a slightly different way, and it will still create steam and then turn turbines and all that sort of stuff. So there are other fossil fuels that you can burn. You could even burn things like wood or other bits and pieces of trash, for example, but they're not as efficient as the fossil fuels.
Banu wants to know, how heavy is coal? Is it heavy or light? That piece that you had,
Yeah, that's
was that
interesting.
heavy or was it really light?
Well, I picked it up. I thought it was going to be really light, like charcoal is. But charcoal's quite different. Charcoal's burnt wood, and because it's wood, that's already quite light. Whereas coal, it's actually just a rock, so it was kind of similar to picking up a rock of that same size.
St Joseph's Hawthorn want to know, where are Australian coal mines located? Where are some big areas for coal mining?
Some of the biggest ones around the Hunter Valley in New South Wales. That's a really big belt of coal mines. But there's also a bunch in Victoria, and they're scattered right across the country. And we've got different types of coal. We've got brown coal, we've got black coal, and there's different deposits of brown and black coal all over Australia. Like I said before, Australia is a really rich country when it comes to coal. We've got one of the biggest coal reserves in the world.
St Joseph's also want to know, how can schools use renewable energy?
Well, I mean, a lot of schools these days have solar panels on their roofs. I mean, a lot of them are investing in getting solar panels there. I don't think there's many that have wind farms in the schools, but we have heard from a school who has a wind farm nearby, and they're powered by the wind farms. And I think as well, like I was saying before about, people who are buying power having more of a choice these days, either you can install renewable energy like solar panels on a roof, or you can actually go for companies that have more renewable energy in the energy that they're sending to your school. So that's about changing or thinking about changing your energy providers.
Cody from Woodend wants to know, why would the world be different, or how would the world be different if we didn't use coal at all anymore?
There'd be a lot less carbon dioxide. Like we were talking about before, those billions and billions of tons of coal that are burnt each year, that's releasing lots of carbon dioxide into the air, and that's affecting, scientists say, the climate change that we're seeing at the moment. So I think if we got rid of coal altogether, a lot of scientists say that that would make a huge difference in slowing down climate change.
Although economically it would have some impact too, wouldn't it?
Yeah, I mean, that's one side of the equation, and that's the other side of the equation. I mean, if we just stopped burning coal altogether right now, a lot of our electricity systems would probably stop in Australia. We rely a lot on coal. I think in Victoria, it's like 90 or 95% of their energy comes from coal at the moment.
And overseas, it's quite similar too. In places like China, developing countries really rely on coal because it is cheap power.
Yeah.
So Jesse wants to know, is the decision about coal, is it a state thing? So can different states do different things? Or does the federal government tell us how much coal we need to use?
It's more a state thing. I mean, the federal government has a policy at the moment. I think it's 23.5% as their reduction of greenhouse gases. And that's their sort of goal, and they're trying to reduce things like coal and other greenhouse gases and bring in more renewables to get to that target. But really, in terms of implementing this stuff, a lot of the time it's state governments that have been taking the lead. So for example, in South Australia, where we are, we're at about 40% renewable energy now. A lot of that's from solar and wind. Whereas other states, like I mentioned, Victoria, I think they're about 5 or even less than that percent. So I think states can make a huge difference. They can invest a lot. A lot of the time companies can jump in and make a difference as well by investing. But they all kind of work together to move towards these goals and to gradually put more renewables in the mix, or figure out whether they want to do that.
Okay, last question, and then we've run out of time, but Woodend Primary School have a joint question here, and it's a really complex one, and we probably can't answer it. So I'm just going to say that right now, because I think, I have a hunch, again, Carl's the scientist, he knows, but I have a hunch this would be a really complex answer, but I'll just throw it out there anyway. So Woodend said, I would have thought that burning coal at a higher temperature would release more carbon dioxide rather than less, which in your head, that kind of makes sense. How does this work? Is it in any way possible to explain without having a PhD?
Look, I mean, I think the PhD guys would really love to answer this question. My very basic understanding of it is when you've got the higher heat, you're able to break up more of those little carbon atoms in there, break it apart, pull it apart, wreck it with that extra hot heat, and get rid of a lot of that carbon dioxide that's being produced in the process. That's my understanding of it, but I reckon jump into Google Scholar, look for your favorite science journals, have a read through if you can, and figure it out from there. Or even ask someone like a scientist or a PhD student, because they would have much better answers for those things than I do.
And in the meantime, you can just watch this carbon dioxide molecule Bounce around the screen.
It came from this shirt, didn't it? Because it's just a Cole shirt. Oh, bummer.
Okay, that brings us to an end. Thank you for all of the schools that sent in questions today, especially our new schools for Ask a Reporter. Thank you very much for joining us. We very much appreciate it. Thank you, Carl.
Thank you very much for joining in, guys. And if you would like to draw either of us as a piece of coal, feel free to send your pictures to Ask a Reporter and to Behind the News on Twitter.
That is fantastic. Next week, we're going to have a really good one for you next week. We are doing a story on why whales get beached. You often see it on the news. Heaps and heaps of whales end up on a beach somewhere. So we're going to look at why they do that and how people help them when they're on the beach. And then we're going to do an Ask a Reporter all about whales and why they get beached and some of the theories around that too. So if you're a whale fan or worried about the health and safety of whales, then tune in next week for Ask a Reporter. We will be here. Amelia will be in the hot seat and it will be lots of fun.
It's going to be a whale of a time.
Oh, well done.
Well, no one said beach dance bros. We had to add something in there. So.
Well done. That's a nice place to end. Thank you, guys. Have a good weekend.